Directions and objective. Directions. Add these notes to your existing unit notes. Objective. You will be able to explain how the hexadecimal number system works. You're going to be able to convert numbers from hexadecimal to decimal, and likewise convert numbers from decimal to hexadecimal. Base 2, or binary, is a number system in which there are only two symbols used to represent any number. Those are 0 and 1. And even with these limitations, we can use these zeros and ones to count up to any number. Like binary, the Base-16, or hexadecimal system, is also used in computing. Anyone who has designed a web page has encountered hexadecimal values when doing colors, and hexadecimal is also used in networking. Okay. One of the most common uses for hexadecimal is colors on websites and images, but we're going to talk more about that later. Hexadecimal uses all 10 digits from the decimal system in addition to the letters A through F to represent any number. The letters A through F represent double-digit values. So A is 10, B is 11, C is 12, D is 13, E is 14, and F symbolizes the number 15. With hexadecimal, each place value is found by raising the base, which is 16, by the power of n, where n is each exponent. So in the 16 to the zeros place, we have the value of 1. 16 to the power of 1 is the 16th place. 16 to the power of 2 is the 256th place. And 16 to the power of 3 is the 4096th place. Note that we can go higher than 16 to the power of 3, but the number is so large, we just stop there because we don't really deal with numbers larger than 4096. It's time to count. Okay, so let's take a look at the decimal, binary, and hexadecimal equivalent of some numbers. So 0 in decimal is 0 in binary and 0 in hexadecimal. 1 in decimal is 1 in binary and 1 in hexadecimal. 2 in decimal is 1 0 in binary and 2 in hexadecimal. I'm going to skip forward a little bit, and what you're going to notice is because hex and decimal share the same 9 digits, there's no change until we hit the value of 10. So 10 in decimal is 1 0 1 0 in binary and A in hexadecimal. For 11 it's B, 12 it's C, 13 is D, 14 is E, and 15 is F. We stop at F. The number 16 in decimal is represented by the hexadecimal value of 10 or 10 because there is a 1 in the 16th place and a 0 in the 1's place. You convert decimal to hexadecimal in a similar fashion as you do from decimal to binary, except this time you're using 16 as your base instead of 2. So let's do a few together so you can see how easy it is. Okay, so now I want you to pull out a piece of scrap paper from your notebook, and you're going to solve these problems along with me. And at the end of the video, you're going to be asked to do some problems on your own, and you're going to have to turn that piece of paper in. Okay, so the problem is convert 99 decimal to hexadecimal. And to do this, we solve left to right. we're going to start at our leftmost position, which is the 4096's place. We take a look at our original number and we say, is this number divisible by this number? If the answer is no, we put a 0. Okay, 4096 does not go into 99, nor does 256. So we're going to put another 0 in the 256's place. However, 16 is a number that can go into 99. 99 is divisible by 16. And it's divisible by 16 6 times, because 16 times 6 is 96. So we're going to take that 96 and we're going to subtract it from our original number. Our remainder is 3. So we're now looking at our remainder number, and we're moving to the right now, and we're saying, is this going to go into 3? Is 3 divisible by 1? The answer is yes, 3 times. So we say 1 times 3 is 3, and we do this until our remainder is 0. So 99 decimal is equal to 63 in hexadecimal. Okay, let's take a look at another one. This says 125 decimal to hexadecimal. So we have a 0 for our 4096's place. 256 is too big of a number, so we're going to put a 0 there. However, in the 16th place, 125 is divisible by 16. If I say 125 divided by 16, I get 7. And 16 times 7 is equal to 112. So I take 112, I subtract it from my original number, and I get, let's see, 13. Okay. Now, moving to the right, my ones place, obviously, I put a 13 here because 1 times 13, sorry, is 13. And my remainder is now 0. However, there's a problem here, because 13 is not a digit used with hexadecimal. So we have to replace that with a what? With a letter. So let me erase the 13, and in the place of the 13, instead, we're going to put a D. Okay, remember, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So instead of putting 1, 3, or 13 there, you have to put a D. All right, so now we're going the other way. We're converting hexadecimal to decimal. So what we do is we plug in the values like so. Okay, so we have a B in the 16th place and a 3 in the ones place. All right, the value of B is, as you guys should know now, is 11. So we're saying 11 multiplied by 16, oops, sorry about that, is going to be 176. So we take 176 and we add it to this value here, which is 1 times 3 is equal to 3. So 176 plus 3 is 179. So B3 in hexadecimal is equal to 179 in decimal. This is our value. This is our number. All right, we're going to do one more together. It says convert 1F hexadecimal to decimal. So, let me get my pen out here. Plug in our values. We have a 1 in the 16th place and an F in the ones place. This is 16, right? Because we have 116 plus F ones. We know F is equal to 15. So 15 times 1 is 15. And our answer is 31. So 1F in hexadecimal is equal to 31 in decimal.